Problem 10. Use implicit differentiation to find an equation of the tangent line to this curve. So you have a y here, y as a part of an argument of sine. So obviously you need implicit differentiation because we really cannot solve for y explicitly here. Okay. So you want to find dy dx, which will give you slope. At this point, you have slope, you want to write tangent line equation. Notice, equation of a line can be written in several ways. One is point slope form, another is the slope intercept form, and one is the standard form. They are not saying which form, okay? So we will have to try and input 3 different forms, okay, if needed. Let's see. First, find dy dx using implicit differentiation. Take derivative of this equation with respect to x. D by dx of the left hand side is d by dx of the right hand side. Left hand side, this is chain rule. Derivative of sine is cosine, object inside as it is, times go inside, take the derivative of this. Derivative of x is 1 plus derivative of y is dy dx. That's the left hand side, equals derivative of the right, because I'm taking derivative with respect to x. Derivative of 2x is 2 minus derivative of 2y is 2 times dy dx. Aha. So I have a dy dx here, I have a dy dx here. I need to get them together. So distribute the cosine x plus y. Cosine x plus y times 1, cosine x plus y. Cosine x plus y times dy dx is cosine x plus y dy dx equals 2 minus 2 dy dx. Fine. Get that guy, negative 2 dy dx to the left and get this cosine x plus y to the right. So that came here, became plus, this went there, became minus. Now you have dy dx common factor, get it out. You have cosine x plus y plus 2 as one factor, and then dy dx equals 2 minus cosine x plus y. Divide both sides by this factor. You get dy dx equals 2 minus cosine x plus y over cosine x plus y plus 2. Now this is the derivative dy dx, but I want slope at pi. In other words, I substitute x equals pi, y equals pi. So derivative at pi is 2 minus cosine pi plus pi over cosine pi plus pi plus 2. Cosine 2 pi. Cosine 2 pi is 1. Cosine 2 pi is 1. I get 1 over 3. So this tells me slope of the tangent line is 1 over 3. My point is pi. So if I have a point AB and slope M, equation of a line is y minus y coordinate equals slope times x minus x coordinate. That's called the point slope form. Once I have the point slope form, I use this slope, this point. Y minus y coordinate equals slope times x minus x coordinate. This is the point slope form. Let me try whether it accepts it, right? Y minus pi equals 1/3 times x minus pi. Y minus pi. In web work, you just have to write pi. That's pi. Equals 1/3 times x minus pi. Let's see whether they accept it. They do. We are done. If they hadn't, so looks like they resolve it themselves, okay? If they hadn't, let me continue explaining here. Distribute the 1/3. You get 1/3 x minus pi third. Move the pi over there. So add the pi. You see that negative went to the other side, becomes positive. Pi minus pi third is positive 2 pi third. So you see, what did I do here? I have isolated y. Y equals x over 3 plus 2 pi. When you solve for y, what you get is called slope-intercept form. Okay? So I simply moved this to the other side and simplified, got the constants together, x part by itself. This form is called slope-intercept form. If WebWork had not accepted my original form, I could have plugged in this form and checked. If I get the x over 3 to the left hand side, then I would have y and x on one side and pure number on the other side. This form is called standard form. Okay, so notice point slope form is from the formula. Okay, y minus y coordinate is slope times x minus x coordinate. That is called point slope form. If I simplify this and solve for y by itself and equal x slope times x plus something, that is called y-intercept. This is called slope-intercept form. At the end, if I get x and y together and pure number on the other side, this is called standard form. You could try any one of these forms, okay, and see which one is acceptable. Every one of these is correct. All right. So let's try the next problem, see whether it's a very long problem or not. Suppose y equals square root x over x plus 7. Find equation of the tangent line and find equation of the normal line at the same point. Normal line is perpendicular to the tangent line. That's all. So slope, whatever you get, its opposite reciprocal is the slope for normal. Okay. Y is square root x over x plus 7. I'll write square root x as x to the power half. When I take derivative, I use quotient rule. Square the bottom right away. Derivative of the top, half comes down, half minus 1. Denominator as it is, minus. Numerator as it is, derivative of the denominator. All right. So, power half minus 1 is negative half. That's all. So, half times x to the negative half, x plus 7 as it is, minus x to the half. I don't like this power negative half. I don't even like this half. So, why don't I write this as a fraction? So, if you look at this fraction, x plus 7 is a numerator because it does not have negative power. So x plus 7 is on the top, that 1 is on the top. So 1 times anything is itself. That 2 comes below, that is 1 over 2, right? That 2 comes below. Negative exponent goes below, becomes positive exponent. Minus, I have just rewritten x to the half as a fraction over 1. Denominator as it is, no problem. Now look at the numerator. I can write a common denominator 2x to the power half. The first fraction is good because I have all of the denominator here. So I write x plus 7 as it is. Minus, this guy needs to be multiplied by 2x to the half. So I have a 2 and an additional x to the half. X to the half is what we call x to the 1 or simply x. Notice I have written this numerator as one fraction and I am dividing by x plus 7 quantity squared. I've rewritten it like this so that I don't have a complicated fraction. Now division by a fraction is multiplication by the reciprocal of this guy, 1 over. You understand where that 1 came from? 1 is the denominator of this guy. So division by a fraction is multiplication by its reciprocal. Now here, minus 2x is minus 2x here. X minus 2x is negative x, plus 7 is plus 7. 2x to the half is fine. Everything looks good. Okay, numerator, denominator. So I have finally gotten the derivative. X to the half is square root x. Now, what is the point in question? 9, 3 over 16. In other words, x coordinate is 9. So the derivative at 9, plug in x equals 9. X equals 9, x equals 9. I have upstairs is negative 9 plus 7, negative 2. Here denominator square root 9 is a 3. 9 plus 7 is a 16 inside. Square all of this 2 cancels, negative 1 over 3 times 256, negative 1 over 768. That is my slope and that is my point. Point was given to me. So equation of the tangent, again point slope form, y minus y coordinate is slope times x minus x coordinate. Let's try and plug it in and see whether they accept it. Y minus 3 over 16 is negative 1 over 768 times x minus 9. Okay, I'll come to that if they don't accept it. But if they don't accept it, be ready with slope-intercept form and standard form. What is slope-intercept form? Move the constant to the other side, get x by itself and take care of the constants, right? In other words, I have done the simplification and this is my answer. What is standard form? Get the x and y together on one side and pure number on the other. So these are 3 different forms. Let's see which one it accepts. What about the normal line? Well, normal line is perpendicular to the tangent line. Slope of my tangent line was negative 1 over 78. So slope of my normal line will be opposite reciprocal. So positive 768. Okay. Slope will be positive 768. Point is the same. So it's essentially this equation except the slope is different. So let me cut and paste. And that's my slope. Let's try. It accepted. Okay. Until next problem then.